All right, guys. Good morning, everybody. I want to give you today an instruction class about the rates of reactions. Please make some notes. Yeah. I hope this is very useful for you guys, and hopefully we can go through the different units that we have to discuss. Last time we discussed the difference between endothermic and exothermic reactions. Now remember, endothermic reactions absorb energy and exothermic energy reactions release energy. Okay, what are we looking at? Yeah, we're going to see how we can increase the rate or decrease the rate of a reaction, some of its importance in everyday life. Yeah. Some reactions can take place slowly, but we can speed them up. And some reactions are actually too fast and they need to be slowed down. Yeah. Okay, and then, well, some reactions they can be carried out at a lower temperature, which is more beneficial as energy costs a lot of money. Okay, yeah. Now, just to remind you, if you're making notes, I just go through the through this unit, but you can just stop the video, pause the video, and make some notes. I think the screen is very clear. Okay, we're going to look at changes. What will happen with the rate of reaction when we change the temperature, when we change the concentration in solutions, when we change the gas pressure, change of surface area of solids, and the presence of a catalyst. Yeah? All of these have an effect on the rate of reaction. One clear note, we never say that a reaction goes faster or slower, or the speed of reaction. We really state that the rate of reaction increases or decreases. This is definition. So when there's a question about what will happen with reaction, if the rate increases and you say it speeds up the reaction, you get 0 marks. Okay, so just remind, better say, have to say increased rate of reaction. Okay, now let's first look how reactions are taking place. Yeah, and we're making use of the collision theory. Okay, obviously, when reactants want to react with each other, they need to collide with each other. If there is no collision, there is no chance of taking a reaction taking place. Yeah? So, one of the things that needs to be reaction takes place, one of the factors is that they need to collide with each other. Okay? Make that very clear. Okay? So, but not all collisions lead to a reaction. Yeah? They need something else. Yeah? So, they need a minimum amount of energy. And this energy is called activation energy. Yeah? For example, if I just open a valve of a gas, of the Bunsen burner, will it burn? It will not burn. What do I have to do in order to let the gas burn? I need a lighter or phosphorus to start the reaction. Now, this starting of the reaction, this is what we call the activation energy. Reactions need to collide and need to have enough activation energy. So there needs to be an input of energy. Yeah? Okay. Alright. So, according to the collision theory, When will the rate of the reaction increase? Obviously, when there are more collisions between the particles and there's more energy in the particles, the reaction will go faster, so it will increase the rate of reaction. So, in order to increase the rate of reaction, we need to increase the particle speed. Can you figure out how we could do that? Or we have more particles present. Could you figure out how we can do that? Think about it. Yeah? Alright. We need more successful collisions. Yeah? Give particles more energy, or another way is to lower the activation energy. I will talk about that. How we do that. Okay? Alright. Now, these factors are the main factors how we can increase. And remember, we always talk about the increase of rate of reaction. Yeah? The following methods can be used, and we will go through each method. But you need to know. First, when we are talking about solids, we need to increase the surface area. If we want to have the particles move faster, we increase the temperature. If we want to lower the activation energy, we add a catalyst. If we increase the concentration of the reactants, we get more particles, which means more collisions. And when we increase the pressure of any gases, we also increase actually the amount of particles in a certain volume. Yeah? Shine light, we don't discuss that really too much, but there's also an input of energy. Okay, let's first talk about how can we increase the rate of reaction by increasing the surface area. Okay? When we increase the surface areas, we have actually a way bigger surface area. That means that more particles are exposed to each other. Okay? Meaning, especially, it's better to have powdered solids than large lumps. Yeah? Large lumps have a small surface area, powdered solids have a large surface area. Okay? How can we use catalyst? Yeah. We use catalyst to lower the activation energy, but also we can increase the reaction rate by increase the surface area of catalyst. Okay? Okay, let's look at an example. Now we have here a surface area, a lump, and we can calculate the surface area. Yeah? And in this case, it is 30 square units. Yeah? Look at the cube. 9 here, 9 here, 9 here, 9 here, plus 3, 3, 3, 3, 3, the other side, and in total 30 square units. What will happen if we divide the blocks? Yeah? And we're going to cut the shape into smaller pieces. Okay? Then we have a new surface area. Yeah? And you clearly can see that we have no more surface area. And if you would make a calculation, we would see that then we have about 54 square units increase. Yeah? If you keep increasing, or if you keep cutting the pieces, the surface area keeps on increasing. Now, think about this. When we increase the surface area, the particles make more contact with each other, so more particles will bounce against each other and make collision. So, in order to increase the rate of the reaction, you can increase the surface area. Okay? Make a note, please. In the next one, we're going to look how the temperature has an influence on the rate of reaction. Okay? What will happen with the temperature when we increase? Particles get more energy. First of all, more of the particles overcome that barrier, the activation energy. But also, the particles speed up. Yeah? So, when there's more speeding up, there are more collisions. More collisions means more reactions, increase of rate of reaction. Okay? So, during the reaction, remember we talked about the enthalpy last time. That's a form of energy, rises to a maximum. Now, this maximum is the energy needed. Yeah, you see that? Yeah, we call that the activation energy. Activation energy. Okay? So, when there are more particles that have more energy, they overcome that mountain, and then the reaction will take place. Now, let's look at this reaction. Can you see which type of reaction is this? Endo or exothermic? Well, here we have the reactants. Here we have the products. Okay, so the reactants go from a higher energy level to a lower energy level to form a product, so that means it releases energy. Okay? Yeah? Alright. Make a small note of this, and then I will move on. Okay. Yeah? Now, as said, this is the activation energy, has to be overcome to start the reaction, and then only the reactants with the energy equal or greater to this value will react. Okay? So, if they don't have energy, it's like going over a hill, and these particles don't have enough energy to go over the hill, no reaction will take place. Okay? And then it will fall back. See that? If they have enough energy, they will get over the barrier and a reaction will take place. See that? Show that again. Okay. Not enough energy. Enough energy to go over the barrier. Okay? There you go. Okay, now we're going to look at how a catalyst actually is working. Yeah? Okay. How do we add a catalyst? Just double check if the video is still good. Just to be sure. Okay. Yeah, adding a catalyst. It's the same as we discussed, I think it was 1 year ago, when we add enzymes. They also speed up the reaction. Okay? I said speed up the reaction, increase the rate of reaction. Okay? Be careful. Okay. So, what is happening when we add a catalyst? A catalyst provides an alternative pathway and lowers the activation energy. It's very important to know. Yeah? So when you lower the activation energy, there are more particles to overcome the mountain. Okay? Right? So when we decrease the activation energy, that means there will be more particles that have sufficient energy to overcome the energy barrier and react. Okay? So this is our original. Here we have again the activation energy. Yeah. Particles don't have enough energy, but what will happen if we are adding a catalyst? What do we see? We see that the pathway is changing. Yeah? The change in energy of the reaction stays the same. That is not changing. Okay? But only the pathway is changing, and now we have lowered the activation energy. Yeah? That means that the particles can easier overcome that hill and actually let a reaction occur. Okay? So the main thing that we need to know of a catalyst is that it lowers the activation energy and it changes the pathway. Okay? Make some notes, pause the video, and then make some notes. Okay? Alright. Now, catalysts are not used up during a reaction. They only change the reaction path. Yeah? So, when a reaction has been taking place, all the catalysts are still there. So we can reuse and reuse the catalyst. Yeah? Catalysts are a billion-dollar industry because can you imagine if you can lower the activation energy? That means you need less energy or less heat for a reaction. That means less money. Yeah, so that means it is cheaper to make products. All right. And they are especially used in increase in temperature results in a lower yield due to the shift in equilibrium. But we come to that another time. Okay? So, some examples that we use include Haber and contact processes. Okay? Some useful points that you need to know for the catalysts. Okay? Catalysts are widely used in the energy. It allows reactions to take place at lower temperatures, so that means it saves a lot of energy and reduces carbon dioxide output. It enables different reactions to be used, and we get a better atom economy, reduce waste, and a lot of catalysts are often enzymes, which are also in your body, yeah? And they generate specific products, operate effectively at room temperatures, okay? They have a huge economic importance in the industrial production of polyethylene, sulfuric acid, ammonia, and ethanol. And these products are widely used in other products. These are like basic products. And it can reduce pollution because you use less heat, okay? And you can keep on reusing the catalyst, okay? Make a note of that, and then we continue. All right. How does the increase of the concentration of solution affect the rate of reaction? Okay. Now, what will happen if we increase the concentration? We have more particles in a certain amount of volume. When we have more particles in a certain amount of volume, we have more correlation. So when we have a low concentration, we have a low collision rate. If we have a high concentration, more collisions are taking place faster, so increase of the rate of reaction. So it actually boils down that we have a higher frequency of collisions making the reaction faster, increase the rate of reaction. Okay? The same happens when, just make it, I'll give you time to pause the video and make a note of this. Okay? Now, how does it work for increasing the pressure? The same way, let's say, how can we increase the pressure? Let's say we have a bin here with a movable lid. Okay? And let's say we have our particles that want to collide with each other. Okay? Now what I'm going to do is move this lid down. That means there will be an increase of pressure. We move the lid down. Again, we have our particles. Now what we see actually is that they are more concentrated. That means again, more concentration means that we have more collisions, meaning a higher reaction rate. Okay? Right. Okay. So, when we increase the pressure, it forces the particles to get closer, and it increases the frequency of the collisions, so the rate of reaction increases, and that's why you will see that in a lot of industrial processes, reactions take place under a high pressure to increase the rate. But it could have an adverse effect on yield, but we're not going to discuss that. We're only talking about the rate of reaction. Okay? So, more particles in a given volume, greater pressure, more collisions, higher rate of reaction. Yeah, simple as that. Alright? A little bit about light, but we don't discuss that in here. But light is mainly used in, well, a very good example is photosynthesis. Remember, during day, photosynthesis will take place because there's more light. If there is more synthesis, if there is more sunlight, then the photosynthesis goes faster, yeah, etc., etc. Okay? Okay. Now, how do we measure the rates of reactions? And there are different ways to it, and maybe I can show you a little practical, maybe some other instructional videos that show clearly how you can measure the reaction rates. Okay? Alright, but let's have a look. Right? Now, remember in the beginning we have all the reactants together. Yeah? That means all the reactants are relatively in high concentration. But over the time the reactants are going to be used up. So this will have an effect on the rate of reaction over the time. Yeah? Let's look at that. Let's look at this reaction. We got reaction A plus B is making C. Yeah? A B are the reactants and C is the products. Okay? Now, let's look good at the colors, what is going to happen over the time. Please make a note of this, is very important. These curves are very important. We have reactant A, and we have reactant B. Okay? Now, A is going to be used up over the time. B is going to be used up over the time. And we have a little bit more of A particle, depends a little bit, okay? On the limited reagent. And then we have the product here, C. And what is happening here? We have to look closely. You will see here that the curve is very steep. That means at the beginning of the reaction takes place in the highest rate. Now, during the time, A and B are going to, the amounts are going to decrease, meaning the amount of particles is going to increase and concentration is going to decrease, meaning that the amount of products formed in a certain amount of time is going to decrease up until it slows down here to 0. Can we say at this point simply the reaction has stopped? This is a very common question in the IGCSE chemistry. How can you see from the curve that the reaction has stopped? Simply because the curve of the product has been flattened out. That means no more additional products are formed. Okay? So, again, steeper curve means faster reaction. Reactions start off quickly because of greater chance of collisions. We have more A and B particles, and then reaction slows down as there are fewer reactants to collide. Okay? Make it over this. Alright. Now, this is interesting to know. How can you measure the rate of reaction? There are different ways to measure the rate of reaction. You can look at how much of the reactants are used over the time. Or you can look at the amount of products that have been produced over the time. Okay? Yeah? Amounts of reactant use. For example, you could add calcium carbonate in an acid. Then the calcium carbonate is going to be used up. You could put it on a weighing scale. Gas, carbon dioxide gas is going to be going to get out. So that means you could measure it because there will be a decrease of the mass. Or for the same reaction, you could actually measure the amount of carbon dioxide formed. Yeah, you can syringe to it, and you could measure the volume of the gas. Okay. Now, let's look a little bit again how we interpret the graphs involving the rates. Okay? Now, if we look at products, and for example, we use different concentrations of hydrochloric acid by adding calcium carbonate. Calcium carbonate. Okay? Now, we have seen X, B, and A. Now, what do we see is that this curve is not as steep as the red curve. So there must be a higher concentration here of, for example, carbon dioxide, calcium carbonate, sorry, hydrochloric acid. Okay? Or we even increase the concentration of the hydrochloric acid, we see a steeper curve. Okay? Come to that later how that really works with different types of reactions. Okay? Alright. If we interpret the graphs involving the rate, in this case we add magnesium to a dilute hydrochloric acid. Okay? I will show you the setup and then we continue the slide. Okay? So how do we collect for the reaction of magnesium with hydrochloric acid? We get, what is the reaction? Magnesium plus hydrochloric acid. What are the products? You should know. That is magnesium chloride, and that is the salt that will dissolve, and we get hydrogen, and hydrogen is a gas, this is a solution, and this is a solid. Okay? Now, how can we measure the rate of reaction? Okay, it's pretty simple. What we do is we add magnesium, magnesium, hydrochloric acid. We put the magnesium in the hydrochloric acid and then we add a stopper with a syringe. So, the next picture we have hydrochloric acid, HCl, and here we have our ribbon, and we get our magnesium, and we get here our H2. What we do is we put a stopper directly when we added the magnesium, stopper with the tube, and tube, stopper, last tube, yeah, and then we have here a syringe, as gas is coming in here, syringe is going to move. Going to move this way, yeah, and the volume is going to increase, and we can measure the volume of gas, for example, each 10 seconds. Yeah, so we need a timer. Okay, so, and well, at a certain moment this will move up to the right until no more gas is formed, and then we can actually use our data to put in, yeah, make a table. Here we have time. 5, 10, 15, well, I said every 10 seconds, huh? So I should be consequent. So we have here time, volume, H2, 10, 20, 30, 40, 50, 60. Let's say this is in milliliters. Let's say the first 10 seconds we get 20 milliliters. Then we get after 20 seconds we get 30, 35, 37, 38, 38. Now here we know the reaction stops because there's no more hydrogen formed. Okay? Right? I hope this is clear. Okay? Make a note of this, and then you know how we can measure actually the rate of reaction. Okay? Now, normally in class we will do that, but because we don't have time for that. We could look by how can we change? How can we change the rate of reaction? Well, change, or I better say, how can we increase this rate of reaction? Well, we can cut the magnesium strips into small pieces. Yeah. What have we done? We have actually increased the surface area. Or we can increase the concentration of HCl, the hydrochloric acid, or we can put a button burner on bread or our heating plate and keep the temperature constant, increase the temperature. Okay? And another way would be using, we could add a catalyst. Okay? But this is how we can measure the rate of reaction, but also how we can measure the rate of reaction when we change the surface area, cut the magnesium in smaller pieces, or increase the concentration of the hydrochloric acid, more collisions, or increase the temperature. Okay? Alright. Make a note. Pause the video and make a note. And then I continue. Alright. Okay. Good. Double check the video still working. And it is. Okay. Yeah. So there are different types of reactions that we could do this. As I told you, we also could do the reaction of calcium carbonate with hydrochloric acid. It is more or less the same. Okay? So, magnesium ternate are added to the hydrogen chloric acid. You did that. You made already all your data. In this case, we have here the volume of hydrogen in cubic centimeter, which is equal to milliliters. Yeah, we could measure it with a syringe, as I told you. And here we have the time, yeah, and you are checking your data. Okay, yeah? Now, at the start, as I told you, you will see that the reaction goes fast. Simply, if we would make a gradient here at A, it is very steep. Okay, so at A, it is very steep. Simply, the reactants are starting and we have most of the reactants, so the highest concentration. Okay? At B, you will see already the gradient is lower.